So, first thing that I wanted to kind of start with was just kind of going over Schoology and looking sort of at everything that kind of my expectations, just review expectations and procedures and stuff. We have a lot of new people in our class, so I just wanted to kind of take a little bit of time to go through some of that stuff. So, if we look at our Schoology page. All right. So if you're ever wondering what to do, if you don't know what is going on, you got to look at the pacing guide. So the pacing guide is going to tell you what kind of I am expecting you or I want you to kind of do every day. So again, for today, if we look, all that really is the Class Connect and the Class Connect assignment. We do have in-person drop-in days. It's actually my shift, so I will be at the district office tomorrow from 9 to 12. If you would like to stop in or come see or have questions, I'm more than willing to do that. Kind of how our classes work, how our class is structured. And then if you ever can't find, if you ever have to miss, this is where the link, the recording link is posted. It's a spreadsheet. So kind of how class works is there's going to be some sort of videos or notes. These videos actually aren't me, but this guy does a great job of giving different examples. And then once you watch the videos, then you try the assignment. Okay, that's kind of the structure: is watch videos, take notes, try assignment. Watch video, take notes, try assignment. Excuse me. So like if we look at today's and then this one again, there's a Desmos link. I believe I updated the link if the link doesn't work, but I try to use Desmos anytime I can. It's a great tool to use to help you kind of figure out these dot products and vectors. So definitely take a look at that. I'll probably cut our Class Connect a little short, John, just to let you get time to do this Desmos because it's a great activity. And then again, this is the video that I made. So again, watch the video, take the notes, and then you can try the assignment. I do provide the notes, blank notes. You can take notes however you want. You can download those. You can print them off. You can just copy what I say. And then this is my copy of notes. Oh, we did get another person. Yay. Hi, Ashton. Bummer. I wish. So welcome. We just kind of got done going through Schoology and just kind of looking at stuff. Definitely take a look once I get the recording posted. This Class Connect will be recorded right here. Because you're going to want to, I know since you're new at the semester that it'd be helpful to hear what we just said, but we kind of just finished. You were able to get into the Desmos activity, right, Ashton?
Yeah, I was.
Awesome.
It worked
Yeah,
after you updated that, so it worked.
Sweet. Okay. So awesome. Making sure. All right. So again, what I usually try to do is recap stuff, review kind of for this Class Connect these last 2 weeks, and then also give you time to practice and do stuff on your own. So we're gonna kind of go through it. There's actually one here. So I'm gonna post a link in the chat. You guys can, well, you can join it, but I think we'll watch the video together. Let's see here. Where's the chat box? So go ahead, click that link. But I'm still going to share my screen and we're going to watch the videos together. There we go. All right, so this is just going to be a quick review of polar and rectangular coordinates.
So let's go ahead and plot these points. Now, if you guys were looking into plotting these kind of points, you might look at this and say, I'm probably not very good at graphing these, especially with radicals. I'm not really sure, at least I understand this. However, I do recognize a point that I'm kind of familiar with, the 1/2 kind of square root of 3/2, right? So I can probably estimate where that is. I kind of drew the unit circle here. I remember that 1/2 square root of 3 is on the unit circle, and it has an angle of 60 degrees, right? Or pi over 3. So it probably is like somewhere right around there, right? Now, before I start trying to get to the next one, I realized this one, okay, that one's gonna have a horizontal distance of 1, but crap, like I don't know the square root of 3, like I can estimate it, right? But, so then we look, is there a relationship here between this and this? Yeah, it's just what? Just twice as long. So again, think about this, like if the distance from here to here is 1, what do you think the distance from here to the origin is? 2. And then this one, the relationship from here to here is? How far? What do you, oh, sorry, I keep on forgetting to do this. Sorry, that's a 3. 3. And what about this one? I think you guys get the pattern by now. So, this is what we call a polar graph, okay? A polar graph has a series of rings, which basically represent the distance from the origin, okay? And these rings are on an XY axis, okay? So the XY axis is not like it's gone away. It's just that now we're taking this ring. Now you can see, obviously, I do not have a very clear graph. So if I do ask you guys to graph polar points or polar equations, you will be provided some graph paper because sometimes these can be a little difficult. But I just want you guys to see, I drew these lines so you guys can see these represent like the distance away. But again, like if we're just graphing points, like they're just the dots. Okay, now these are the X and Y coordinates, right? These are what we call rectangular. These are what we call rectangular points. And rectangular points have coordinates X and Y, which you guys are familiar with, right? So, however, is there an easier way to graph these? Because if you didn't know that first one, like if I just randomly said to you, graph this, you probably like, I mean, you'd probably get a little close, but it would be kind of difficult. You'd have to like think a little bit on like, where is that? Like, what is that value, correct? Especially if you didn't have a calculator. Would you guys agree? So this isn't really like very efficient. Like rectangular points are great to graph if it's like 2, 3. Okay, over 2, up 3, like easy. But when you have radicals involved, it gets a little bit messy and it's harder to be exact. Would you guys agree? So what we can do, actually one last thing I talk about here. So what we can do is we can represent these points with the relationship. Now, if you guys remember from vectors, like as long as we're like expanding these, like making these longer, like the angle does not change. Like, don't you guys agree that these points all kind of have like the same angle, standard angle, even though they're not actually aligned, but they're like all the same distance away from the origin? Would you guys agree? So we can say they have the same angle, but they're not like aligned, they're points. And that angle we already said is pi over 3, right, in radian form. And then also the other thing that makes these unique from one another is their distance away from the origin. So what we can do is we can classify these points as far as their distance away from the origin, which is another way of saying their radius of their circle, and then the angle from in standard form. So that is what we call polar points. And polar points are in the term of r times theta, which is also written up there on the board. So if I wanted to write these in polar points, I already know this is on the unit circle, so it has a radius of 1, and then the angle we already figured out was pi over 3. So look how easy it is for me to write the rest of these. This one is 2, pi over 3. This one is 3, pi over 3. 4, pi over 3. So you guys kind of see how like polar points can be convenient for us? Like it's pretty simple to go ahead and graph those. And
all right. So that was a real quick review on just rectangular and polar points. Let's see. So go ahead now on your screen and try to type in which point represents, oh, I lost it. 5 pi. There we go. All right. Okay. Let's see here. Can you guys give me your best guess? Which point? I'll pull the picture up. Why is it so small there? Which point represents 5 pi? What do we think? F, E, B, A? Five pi is actually going to be point F. So If I look at this picture again, how many rings do I go out? 1, 2, 3, 4, 5. And then I'm on the angle of pi if I think about my unit circle. Okay, this would be F. All right, next slide.
So what they're giving us in this case is,
Go a little
if we're
bit
going to graph
faster.
this, because I might say to graph something. So we know that this is kind of like a distance of 3 from the center, right? And then the angle is negative 1/3, which is going to be in the negative direction down here. We can say like negative 1/3 or negative pi over 3 is like down there, right? And it has a distance of 3, which will count as like rings. So we can say my point is roughly right around there. Would you guys agree with me? Looks about right, feels about right, sounds about right. So if I'm looking into writing this down, remember our conversion is basically what we're looking for is what are those x and y coordinates? And we did, and you know, I'll show this to you one more time. I don't want you to get this confused with vectors, but I want to again explain this. If we were going to write this as a vector, if we're given our angle and our magnitude, because that's basically what 3 is like our magnitude. If we were going to write this as a vector, our vector would be cosine of theta times sine of theta. And what's nice about that is whatever our vector is, that's going to give us our terminal point. And that's what we're looking for, is the terminal point. We're not really talking about vectors. I'm just relating it to what you've already done. So it'd be 3 times the cosine of negative pi over 3 times the sine of negative pi over 3. Right? And that's going to give us our terminal point of our vector. But we're not really talking about vectors. We're just actually talking about what are the x and y coordinates of this. So all we're simply going to do is for to find x, you're going to do r times the cosine of theta. So that's my r, that's my theta.
So again, that's kind of the key right there, is to convert these. For x, we got to use cosine, and for y, I want you to think about what would we use instead of cosine.
So 3 times the cosine of negative pi over 3. Thankfully, I left that up there. Let's go and look.
Strongly recommend you guys have a unit circle with you at all times, because again, you can, if you can't remember what negative pi over 3 is, you can just look at your unit circle and it'll tell you exactly what it is.
Look at that, guys. Pi over 3, the cosine is 1/2. But if we're looking at negative 1/2, that's going to be in the fourth quadrant. Cosine is still going to be positive, so it's still just going to be 1/2. That's going to be 3/2. Then we do the y, which is r times the sine of theta, right? Because you see,
So that's the difference, is that for our y coordinates we use sine, and for x coordinates we use cosine.
which is 3 times the sine of theta, sine of negative pi over 3. Right? Isn't that what they're doing to find the y coordinate of that vector? Yes, that's what we're doing to find the y coordinate. We're just multiplying 3 times the sine of that. That would give you the y coordinate of that vector. We're not talking about vectors, but again, just a relation. So sine of negative pi over 3 is going to be 3 squared of 3 over 2. However, we're dealing with negative, which is down in the fourth quadrant. So sine is now negative. Very good. So now we have my point, 3/2, comma, negative 3 squared of 3 over 2. To make sure we did this correct, does that at least give us a point that's in the fourth quadrant? Is our x coordinate positive and our y coordinate negative? Yes? Yes? And then if you really wanted to even double check, you guys could see it looks like it's less than 3 rings and more than, and less than probably 2 over there. So if I was just going to calculate negative 3 square root of 3 divided by 2, that's negative 2.5, 2.59. So does that look like the kind of the point on an x and y coordinate over here? Because that would be 1, 2, 3. So you're between 1 and 2. And then 1, 2, and 3, you're at between 2 and 3. Yes, Andrew.
All right.
Yeah, it's like here's the x, here's the y. That's 1, that's
Okay, let's go to the next slide.
that's 3. That's negative 1, that's negative 2, that's negative 3. It's still an x and y coordinate. Yes, we'll be talking about that.
There we go. All right, so again, I was referencing the unit circle. We've talked a lot about this. Make sure I would recommend you have a completed one. You could screenshot this. You can find them on the internet very easily. But again, when he's talking about, hey, where's that? What's cosine of, negative pi over 3? Oh, that's where we got the square root 3 over 2. Hey, what's the sine of negative pi over 3? Oh, that's where we got the negative 1/2. So you can just jump into it and see it, right? But it is nice to have memorized as well. All right, so try this one. Let's look at the full view question. Convert from polar to rectangular. So take 5 135 degrees and follow those that we just watched that video. Take r cosine of 5 and r times cosine of or sine and plug that in. Your R value is going to be 5. And you got to figure out, maybe we look at our unit circle. What's 135? Can I do that? Can I go back to my unit circle? 135. Okay, that's going to be these numbers right here. So I would do 5 times negative square root 2 over 2. And I would do 5 times square root 2 over 2, which I believe was one of the questions. Yes. I believe it would be this first one here. Yep. Nice work. Converting polar. Okay, let's skip ahead. Same deal. Trying to find and see if there's a different one. Otherwise, I want to move on and talk about lesson 4. Okay, we can do these. You can do these later if you want. All right, don't worry about that. So we also talked about unit 8, I believe. 6. Here we go. We also talked about dot products, okay? So again, how dot products work is that we take these vectors and we multiply them together. So you got to look at their like corresponding location. So this is like U1 times V1, U2 times V2. And then that's how you would get U times V. So there's a lot of like properties you can see right here. So an example, this is like in the notes, I know, but 4 times 2 plus 5 times 3, that gives me 8 plus 15, which gives me 24 or 23, excuse me. You can also get something where it looks like this, where you have a U, a V, and a W, and you got to look at what the equation is asking. So first, the equation's asking me to do U times V, and then whatever I get, I got to multiply it by W. Whereas over here, I don't use W at all. I just use U and V. So you got to make sure that when you get these multiple sets, you get these multiple, letters with different, you got to make sure you're using the correct equation as you go through. Okay, and this is to find the magnitude. So dot product of U and itself is 5. What is the magnitude of U? So we look at this, we say, okay, U times U is 5. Well, that means my magnitude, if I undo a squared, U squared, I got to square root it. So that would give me square root of 5. And then this is something that we do ask you to do to find an angle between two vectors. So again, if I'm looking at finding this, the vector of this between U and V, I would use cosine theta. Again, finding cosine of U times V on the top of my fraction, and then on the bottom of my fraction, and I find the magnitude of U multiplied by the magnitude of V. So if we look at this example, find the angle between 4,3 and 3,5. Again, this is my general equation. So if you don't have that written down, you're going to want to use that. I plug in my values. Again, I use 4 times 3 plus 3 times 5. And then I got to find what my magnitude is, which I try to do right here. I actually end up getting some nice numbers because 16 plus 9 gives me 25, and the square root of 25 is 5. So I keep going and I say, all right, I finally finished this. I got cosine of theta to be 27. My magnitude was 5. I find the magnitude of V because I got to use V now, and that's not as nice of a number. That's square root of 34. But when I plug in those numbers, I get 27 on top over 5 square root 34. And if you work backwards, you take the inverse of it, you're going to find that that degree is 22.2. Orthogonal. Okay, real quick, talk about orthogonal. What does this word mean? It means that your angles meet at a 90 degree. Okay, so your two vectors, the angle that you're trying to find, if they cross at 90 degrees, we call it orthogonal. And it also is when u times v equals 0. So you multiply them, u times v, and you get 0. That's another way to determine if it's orthogonal or not. Let's close it up. I will add those. I'm just going to scroll through the questions again. If you want to try them on your own, you absolutely can. Otherwise, keep getting the practice on Schoology. Let's talk about our Class Connect assignments. So again, everyone does them a little bit differently. How I do it in my class is I ask that you look at the Class Connect. You look at the Class Connects after you watch the recording. You guys don't need to watch the recording because you're in it right now. And then you would, sometimes I will tell you that question. So how did I get there? Sorry, forget. So on the main Schoology page, it's right at the top, Q3 Class Connect assignments. I'm going to publish it. And so again, what did you learn? Did you follow along? What did we decide? What were we, it's kind of like an exit ticket. So go ahead, find the rectangular coordinates of each polar point. So again, how do we find out? We need to use r cosine. R is 4. And then for your x coordinate, you find cosine of 3 pi over 2. And then for your y coordinate, you use sine. Convert the polar coordinates to rectangular form, basically the same thing. This time it's a 6, and instead of a pi, it gives you it in degrees. We have to be as comfortable in radians as we are in degrees. And orthogonal is when two vectors meet at a 45-degree angle. That we talked about is not true. Again, because it needs to meet at a 90-degree angle. Anyways, that's all I've got for you today. Again, let me know if you have questions. I know you guys are both new. And then we will